Hello, hello. Welcome to a special bonus video that I'm doing to celebrate reaching 100 subscribers. I really wasn't sure what to expect when I started this channel, whether anyone would watch, but I'd kind of set this random goal for myself of trying to get to 100 people watching without any particular time frame. Just that was kind of my goal. I mean, I used to teach at university, and at any given point in time, I usually had about 100 students. So I thought that was a reasonable number to think about. If I were reaching that many people at a time, it kind of seems to validate the time I'm taking to produce all this stuff. Right when I was teaching, I never thought for a second, I never questioned the value of what I was doing. It was only 100 people at a time. And I think I underestimated how kind of big the YouTube ecosystem is. But anyway, that's all to say. I'm kind of humbled by how quickly I reached that imaginary goal for myself, and kind of excited that people seem to be getting something out of this. Whether hopefully it's learning something, but even if it's just you enjoy watching me push up against really hard puzzles, that's fine too. But so whatever the reason, I'm glad you're watching. And so today I'm going to do a walkthrough of a puzzle that I think is both quite hard, but also emblematic of a whole genre of puzzle that I quite enjoy. So that genre of puzzle is the squishdoku. So this is I don't know if variant's the right word. It's a kind of a cheeky new constraint. I believe was invented by Jay Dyer. And they came up with this, kind of seemingly silly rule set that people have then explored endlessly, trying to find all the nooks and crannies of it. And I think this puzzle in particular really forces you to understand the geometry of a squishdoku puzzle and understand what's going with it. So let's get into the actual method here. So in order to do this puzzle, like I said, you really have to understand the basic framework of how squishdoku works. And I think, at least for me, the way I think about that is to think about this central box. So first, I guess I should explain the rules. What is a squishdoku? So it's kind of like a normal Sudoku in the sense that I've got rows and columns and I've got boxes, although now the boxes are squished together. So I still have 9 3x3 boxes. So the first one is here, box 2 is here, but box 1 and box 2 you can see are kind of squished together, and these 3 cells here are going to appear, so whatever they are, maybe they're 1 2 3, whatever these numbers are, these are going to count as those numbers in box 1 and box 2, right? And this is box 3, 6 5 4, etc. Right? So these lines separate the boxes, but the lines go through the middle of the cells because the cells on the line appear in both boxes at once. And if you're in this cross, you actually appear in 4 boxes at once. So that's the basic framework. And so you'll see that in a row and a column, you don't need, in fact, can't have all the 9 digits. You only get 7 of them. But you still need all 9 in each 3x3 box. And then this puzzle has an additional constraint, which is these cages. Because these cages are big, you should rightfully assume, and it's in fact described in the puzzle description, that digits are allowed to repeat in a cage. So I could have, a 3 and a 3 like that. That would be fine, so long as it doesn't violate any other rule, right? Namely that they can't have 2 of the same number in a 3x3 box, row or column. But all the digits in the box will sum to the total given in the top left corner, in this case 66. So those are the rules of this puzzle. So in order to break into this puzzle, like I said, you really have to understand the geometry of a squishdoku. And to me, the way that you do that is to think about this central box and basically treat all the other boxes and all the other values as being relative to this central box. What do I mean by that? So there's a kind of a frequent coloring technique, right? So if you know that, say, you've got a bunch of 3 4 possibilities. Let's leave that actually not there. right? If you saw something like this, you might start trying to do something like coloring, right? Where you color some of them purple and some of them green, and then you'll know, well, this one doesn't work, but you get the idea that, I guess you would need a green one down here. You could, you don't know which one's 3 and which one's 4, but you can kind of say that, well, all of these, even though I don't know what number it is, they're all the same. And so that kind of a technique is called coloring. It's fairly frequent, but you don't have to actually do it with coloring. People often do it now with letters. So if I call this A, and then if I can somehow figure out that this is also A and this is also A, even if I don't know what the digit is, I can say that, well, A is in whatever A is in one of these, and that might help you make some inferences. Like, well, now I know A is somewhere down here, right? So that technique generally is called coloring. And if you treat this center box as the reference and try to color the rest of the puzzle based on that, you find that there actually aren't that many possibilities for how squishdoku can be laid out. So I'm just going to label these A, B, C, D, E, F, G, H, I. And so this, I'm going to explain this more deeply than you need to know for this actual puzzle, because I think if you kind of have this framework in mind, every squishdoku puzzle that you ever want to try from here on out is going to be much easier for you if you understand this basic layout, way of thinking about the squishdoku. So again, I don't know what these. I know that these letters represent the digits 1 to 9. I don't know which is which, and it doesn't matter. I'm not ever going to place a digit in this explanation of what I'm about to show you. So what you can see from this is that if I think about these boxes, I can start thinking about, well, what letters, which of these 9 letters can actually fill up any particular cell in a given box. So the first thing to recognize, or at least for me, is these corner boxes. These corner boxes are actually quite restricted in the sense that if I think about, how do I place all 9 of these letters? I mean, G's already placed in this one, but how do I place the other 8 letters in this box? Think about the letter D. Where does D go in this box? It doesn't go on this line because it can't be repeat in the column. It can't go on that line because it can't repeat in box 4. So D is going to have to go in the corner here. The exact same logic applies to A. It can't go in the line or that line for the exact same reason D can't. So A has to go in there as well. But I can look from the right and do the exact same thing. Where does H go in this box? Can't be here because it can't repeat in the column. Can't be here because it can't repeat in the box. So H goes here as well. And I is also going to go here for the exact same reason. So those 4 letters, A, D, H, and I, have to go in the corner. And therefore, those 4 cells have to be A, D, H, and I. Right? Which means that the other 4 letters, B, E, C, and F, B, E, C, and F, have to go in the remaining 4 spots. And I can do the same thing with these other corners. So in my head, I don't know if this is the best way to think about it, but in my head I think about it as like these wings kind of have to go point into the center. So these are B, C, D, and G, and that leaves E, F, H, and I on the wings, on these legs. In this corner, I need A, B, F, and I. Oops, I'm going to do that essentially. And then these are what's left, D, E, G, and H. Same thing down here. We have C, F, G, and H in the corner, and A, B, D, E on these. Now, the only thing I have left to figure out is what can go in these. And the answer is, well, not E, right? E can't go in any of these. So E is actually already placed. All the places that E can be, E is going to be on these wings everywhere. And as a side note, one thing that will be true about this is E is going to end up in this kind of windmill pattern where E is either going to show up on this wing, this wing, this wing, and this wing. Right? That's one possible layout for the E's. Or it's kind of going to go the other direction where it's going to be over here and therefore here, here, and here. And the reason that's true is, suppose it's not, right? How could I violate that? Well, one of these wings would have to move over to the other one. But whichever one I move, right, it's going to violate either a line either a row or a column constraint. So I'm going to end up with this windmill pattern on ease. So what's going to go in here? Well, basically the way to think about this is going to be, you can't really think about it as whatever's left, right? Because if I think about it as whatever's left, well, no, actually you can do it that way. That you get the same result. So whatever's left, what do these two cages not see in this box, right? They see D, E, and F. They see A and G. So what's left is B, C, H, I. Right here, what do these see? They see all these five. So these cells can only be A, B, G, or H. Oops. A, B, G, or H. These are D, F, G, I, and these are A, C, D, F. So that's it. Those are all the possibilities for every single cell. And you'll notice that there's exactly 4 possibilities in every cell, right? So right from the get-go, in theory, you could think, well, any of the 9 digits could go in any of these cells. And that's true. But if we think about it in terms of this relative to what's in the center box, that 9 very quickly becomes 4. And that is really going to limit the possible ways that the number of possible permutations that a squishdoku can have. It's much, much less than a Sudoku, standard Sudoku. Now, for the purposes of this puzzle, what's important is, not just that I have these 4 things. I'm going to delete all this because it's not really important. What is going to matter is thinking about, well, for each of these positions, where are the places that can go in the rest of the puzzle? So if we think about, where does A go? Well, A is going to go in this corner and this corner, right? And then it's going to have to go in this box here to satisfy box 6. And it's going to have to go in this box here to satisfy box 8. But it's also going to have to go in one of these lines to satisfy box 9. Now, whichever one it does, so in other words, it can't be something like this, because that would violate, we can't, then A would be in all these places and wouldn't be anywhere in box 9. So it's either going to be something like this, or it's going to be something like this. Those are the 2 possibilities. It's not really 2, because there's 4 here, and then 2 in each of those. But you get the idea that they're kind of 2 general pictures I can draw that will tell me where all the A's are. With the B's are going to go in these corners. Oops. And then they're going to go in one each of these boxes, and then they're going one of these wings, depending on which line it ends up on, or which side of the center it ends up in row 5. So, and again, you can think of this as, it's either going to look something like this, you get this kind of windmill pattern, or it's going to go the other way and you get this kind of windmill pattern. C is going to be exactly symmetric with A, right? It's going to be these, and then either something like this, that's one way around, or it's going to be something like this. F is going to be symmetric with B, right? I won't do it again. It's the exact same idea. The one's a little different, but I've already shown you, is E, right? You get a windmill along the lines in one direction or the other. And what you might have noticed is that when you do that, and this is where we're going to get into what's necessary for this particular puzzle. So each position kind of has this, like, 2 directions of windmill patterns that it can go in. Some have these additional corner box. They all have some additional corner box, except for E, I guess. They all have some additional corner box positions, but, and then, so they're in 2 of the, so let me back up. Except for E, every other digit is in 2 of the corner boxes, right? So B is in those 2, D is in those, not D, what's in those 2? F is in those 2, right? And then a windmill of some number of other places. So for F, right, it's in those 2 corner boxes, and then a windmill like this, or a windmill like this. Oops. One of those 2 windmill patterns. So I'm not going to erase all this. Because you don't have to memorize or think about like what are the 4 possibilities in each box. That will come kind of naturally as you solve it. What's important for this particular puzzle is thinking about how many times each of these 9 digits appears in in the rest of the grid, right? Why does it appear? How many times does it appear in the rest of the grid? So this position, which used to be called A, right? We said was in those 4, one of those 4. So that's 3 times it's appeared so far. And then we get a windmill pattern where it's either like this, that's 4, 5, or like this, that's 4, 5. So this one is going to appear, no matter which windmill or orientation it goes in, this is going to appear 5 times. And the same thing by symmetry is going to be true in all these corner spots. They're all going to appear 5 times. What about these edge? These edge ones, well, this one is going to go in these 2 corner boxes, and then I get a 3 windmill, right? It's either something like this, those 3 spots, 1 each in those 3 spots, or something like this, one of those 3 spots. Either way, I have 1, 2, 3, 4, 5, 6 places that this is going to go. And then by symmetry, that's going to be true in all the other the non-corner edge parts of that box. Now, what about the middle? What used to be called E? Well, I already showed you, right? You're going to end up in one of these windmill patterns, either like this, in which case there are 5 locations, or like this, also 5 locations. So there are 5. So once you recognize this, now you can break into the puzzle. And I'm going to give you a chance to pause the video if you want. See if you can figure out how to break in given, you may just think, well, how is this possibly relevant? This is totally irrelevant. But I promise you it is relevant. So go ahead and pause if you want to give it a try. I'll give a couple layered hints to kind of help you if you're not seeing it. So my first hint, if you're back, maybe you tried, maybe you didn't try because you just thought, no way. My first hint is think about the title of the puzzle. The title of the puzzle is a big hint here. Now if you're back for another hint, right, 240. 240 is what you end up getting if you sum all of the digits in the Sudoku by looking at the cage totals, right? So every single cell in this puzzle is in a cage, and all of the cages have a total in them. So I know the value of all the cells in this Sudoku, which if you're used to normal Sudoku, you might think, well, of course I do, right? I know that's just 45, which is the digits 1 to 9 times. But the squishdoku, some digits, none of the digits appear 9 times, right? They either appear 5 or 6 times. So which digits appear 5 times and which digits appear 6 times is going to matter a lot, right? So if I add all these cages up, I won't embarrass myself by trying to do that. I know it's 240. I've done the puzzle before. That is going to add up to these 9 digits 5 times, right? Plus these 4 digits 1 extra time. So these 9 digits, that's 45, 5 times, that's 225. So there's definitely a total of 225 of each of these digits 5 times. And then these 4 digits, which I'm now going to highlight orange, get 1 extra placement throughout the grid. And so the difference between 225, right, these 9 digits 5 times, and the total of the whole puzzle, 240, is 15. So these 4 digits have to add up to 15. So that's a big hint here. There's still one more step you have to do to place a digit, because there are lots of ways I could make 4 digits add up to 15. So again, go and here, I think if you spend enough time, you can do it. So go ahead and pause if you haven't figured it out yet, and see if you can figure out how to place a digit. And I'll give you one more hint if you came back and thought, I just couldn't do it. The digit I can place is this one. So how do I place that digit? I place that digit by recognizing that these 4 digits sum to 15, but also I know what these 3 digits sum to. How do I know what those 3 digits sum to? Those 3 digits sum to 21 because this whole cage sums to 66, which you kind of can't see because if I highlight it. So this cage, and I'll take the highlighting away, is a 66 cage, right? And this box is all the digits 1 to 9, totaling 45. So 66, this whole cage, right, minus the box, 45, is 21. So these 3 cages, which I'm going to call blue, total 21. So what that means is the orange cages are 15, the blue cages are 21. So the the orange cells are 15, the blue cells are 21. So the blue cells are 6 more than the orange cells. If I delete these, because they're in both the blue and orange, that's still going to be true. This blue cell is 6 more than these 2 orange cells combined. The only way to do that, using the digits 1 to 9, recognizing that they all see each other, is to put a 9 here in the blue cell and 1 or 2 in the orange cells. And I'm actually going to bring the orange back because we're going to need that in a second. So that's step 1. That's the first part of the break-in. Stage 2 of the break-in is to do something similar where I can now place, I know which way the 1s and 2s go around, and I'm going to get 1 extra digit in addition. So go ahead and see if you can look around for a similar trick to what we just did and place 3 more digits. So the final hint I'm going to give you here is that the 3rd digit I can place is the center square. So how do we do it? Instead of looking at this corner cage, we're going to look at this corner cage. So we've got this whole cage adding to 55. Again, those add up to 45. So what I'm left with is this, which sums to 10. So these 2 cells together will add to 10, meaning this is 8 or 9 to make the 1 or 2 work. But this can't be 9 because we already have a 9 in the box. So that's 8, which needs a 2 to sum to 10, and that makes that the 2 and this the 1. So that's the next step. Now, I don't know what these cells are, but I know what digits are in these 2 cells. I just don't know which one's which. So these 2, because I know the sum of the orange cells, right? That's the first thing we figured out. Those add up to 15. And so these 2 are 15 minus this 3, so those are 12. But 8 and 9 are taken. So the only way to get to 12 with 2 digits, given that 8 and 9 are taken and the 2 digits can't repeat, is a 5-7 pair. Which means, and now I am going to erase this highlighting because it's going to get confusing for a second. And I'm going to color these, let's call them red up here and green down here, I guess. I'm going to try to, maybe I should use lettering. Yeah, I'm going to use lettering instead. So I'm going to call this digit, I want these to be ABC because I think these are going to be more important. So I'm going to call this one D in the corner and this one E in the corner. And then these are from 3, 4, and 6. I'm going to call this one A, this one B, and this one C. Okay. So now I have some digits here, and now I'm going to think about some of the tricks that I kind of talked about earlier in this video and see like where I can go around and start placing some digits. So one thing to look at is maybe these corner cages, right? So these not cages, these corner boxes. These corner boxes I know are, right, so in this case it's A, 2, E, and C, right? I could draw that in, I'm not going to because I don't think it's not the fastest way through here. But you can think about that kind of being true in all of these corners. I can think about this one, this is in the corners as well. And then, in some combination of other wing cells. So you could do all that. I'm actually first going to look at this 21 cage. So I tried to look through it. I made a little note to myself, the kind of the most efficient way to get through this puzzle, which is not the way I got through this puzzle. So when I did this puzzle, I actually tried to do it for a stream. And I basically, it was fairly early in my squishdoku knowledge, so I didn't understand kind of the geometry of it that I set up at the beginning of this video. And I basically took 40 minutes, got almost nowhere, and had to turn the video off because I, had to go to work. Um, so I didn't end up using that or trying it, but I did eventually want to do a walkthrough of it because I came back to it later after I'd done some other squishdoku puzzles. It kind of warmed me into thinking about how the geometry works. I came back to it, and I think it's like I think of this as kind of the Sudoku, squishdoku rather, puzzle that you really have to understand how the geometry works to solve it. Anyway, this cage is a 21 cage. So this is again, I don't know the digits here, although I actually do know one of the digits here. But I do know, or in other words, I don't know. I know the 3 digits that make up this 21 cage. I don't know where they go, but then I backtrack that. I actually do know where one of them goes. So I'm going to give you a second again to pause the video. First, think about what are the 3 digits that make up this 21 cage. And then finally, can you actually place one of them? And the hint I'm going to give you is think about what is excluded from everything in the cage. What sees everything in the cage? There's only one number that sees everything in the cage, and that's this corner 9. Right? This 9 sees these 2 from being in box 8, and it sees these 2 from being in box 7. So there's no 9 in this 21 cage. And these 3 all see each other. So these have to be a 6, 7, 8 triple. But if we think about where the center square in squishdoku goes, remember, it doesn't go in a corner box, right? It's one of these windmills. It's either like that or it's like that. So the only place 8 can go in this 6, 7, 8 cage is here on the line. Right? In fact, 8s are only going to go on lines from now on. And once I place this 8, now I know which way around the windmill it goes. Right? So 8s are going to go in, not H, 8. 8s are going to go in each of these, the one, right? I kind of know where the rest of the 8s in the puzzle are, almost, right? Each leg has 2 possibilities. So that's 8. And I don't know which way 6 and 7 go yet, but that's what I have so far. Continuing on looking through cages, I can look at this 12 cage, right? So this 12 cage has to have a 1 in it. So actually I can, right now, I tell you, it doesn't have an 8 in it. So if I place an 8 in it, I need 3 digits that sum to 4. That's not going to work. So actually, I know already that the 8 is going to go here. So back to this cage, what goes in here? I need a 1 for sure. If I don't have a 1, it's 2, 3, 4, 5. That's 14 at a minimum. I need a 2 as well because if I don't have a 2, the minimum it could be is 1, 3, 4, 5. That's 13. And then in addition to the 1 and the 2, I need either a 3, 6 pair or a 4, 5 pair. Where's the 1 going to go? Well, not here, so it's got to go here. Where's the 2 going to go? This kind of goes back to that earlier trick. I know what these 4 corner cells are, right? They're A, 1, D, and C. They're not 2. So 2 doesn't go here. 2 is going to go in one of those cells. So I have 1 and 2 placed here. But now I know also that 1 and 2, by being on this quadruple here, are going to be in this corner cell. So I know these 2 are now a 1, 2 pair. Right? So I have this 1, 2 pair here. And now let's go down to this 13 cage. So I'm going to give you a second again to pause the video. Think about what absolutely has to go in this cage. And the answer is a 1, because if you don't have a 1, you get 2, 3, 4, 5 at a minimum, which is 14. That's too big. So I have to have a 1 in this cage, meaning that 1 can't go here. So this is the 2, this is the 1. And now I know exactly what fills this cage. I don't know the order, but I know the 4 numbers in that cage. So if you don't see it immediately, pause the video. If you do see it immediately, it's 1, 3, 4, 5, right? Because that is the minimum I can make this cage. It totals exactly 13. So that's just what it is, right? This is 1, 3, 4, and 5. Okay, so that's the 13 cage. And now I actually know, well, even before I did that, I could have done this, but in my walkthrough, the next step is I can actually place the 2 in box 7, which is going to go right there. I have a 2 here. And now, I don't know if this is the most efficient way to do it. It's kind of, it's kind of complicated. But I think the next step you have to do here, or at least the kind of the place to find the most progress, is to think about this 22 cage and how I can do it. So this cage is actually fairly restricted in the sense that it's hard to make this cage large enough to fill a 22, right? And that's because this 9 sees everything in the 22 cage by box logic. And these 2 8s also see, I mean, there's no 8 possibility. All my 8s are drawn in somewhere. There's no 8 in this cage either. So it's hard to fill this cage up with digits high enough to get to 22, right? So one way to think about this, and further, these 2 cells, I'm going to start trying to think about what letters they could be, right? So this cell here is in this corner box. So it's either, well, it's not 2, right? It could be A if A were 6. It could be E if E were 7. Or it could be C if C were 6. Similarly with this, this cell, it's either 6 or 7. So, and it's not E or C because they share a box. So if it's 7, it's D. And if it's 6, it's either A or B. So that's a little bit of background knowledge to think about how to work through this cage. So how can I, so let me back up one step. Can I avoid putting a 7 in this cage? In other words, can I fill this up with digits without 9, without 8, and without 7? Now, it's a little bit tricky because digits can actually repeat in this cage. So I could have these 2 digits repeat, or these 2 digits repeat, or these 2 digits repeat. And that would be, the cages do not require all unique digits. So, but I definitely can't have 2 7s, or 2 6s, which is important for if I don't have a 7 in this puzzle, if I don't have a 7 in this cage, how can I get to 22? So let's think about it. Suppose I don't have a 7. How can I maximally fill this? Well, maybe I could put a 6. I would need a 6, but I can't have 2 6s because if I have 2 6s, one is here, which will see this cell. One will be in here, which will see this cell. And so these would have no 6s. So I can have at most 1 6 in this 22 cage. So if there's no 7, if I want to maximize this cage, I can put a 6, maybe put a 6 here. I can have, what if I try to get 2 5s in there? Well, it's actually harder than it seems because of this DE pair. So for example, I can't have 5s in those 2 spots, or in fact, those 2 spots, either one, because this 5 would see this D, wherever the 5 is down here would see this E. And so neither of these could be 5, which would break this box. So if I want 2 5s, it would have to be in those 2 spots. So I could have 6 maybe, these 2 would be 5. But if I do that, then if I have a 5 here, this 5 will see all of these cells. So I can't do that, right? I can't do that because I need a 5 in this 13 cage. So I can maybe have 6, I could have 1 5, and maybe I could have 2 4s. So maybe I could do something like 6 5 4 4. But if I do that, wherever I put the double 4, well, I certainly can't put a 4 here because it would break. Maybe I could do this actually. I could do this. 6, 4, and then I could put a 4 in there still. And then 5, 3. I can't do that either actually because I couldn't put a 3 here. So no matter which way I try to do it, 6, 5, 4, 3. Well, first of all, that's just not big enough, right? Even if I have 3, 4, 5, 6, or 6, 5, 4, 4 even, that only adds up to 19, plus this 2 would be 21. That's not big enough to make the box. So I definitely need a 7 somewhere in the puzzle. It can't be here because it sees both spots. So I have a 7 in one of these 3 spots. And actually, a step I forgot to do, and which I realized as I was thinking about this, is what goes in this cell. I don't know exactly, but I know it's either 6 or 7 because everything else it can see, right? It can't be 1, 3, 4, or 5 because it sees everything in this 13 cage. It can't be 2, and it can't be 8 or 9. So this is either 6 or 7. And now I have this 6, 7 kind of 2 pairs. So I know this one, I'm going to color this purple. I know that these two are the same digit. And further, I know there's a 7 in the puzzle. And so now 7 can't go here. It can't go here. Maybe I could have 7, 6 like that, right? But keep that in mind. There's definitely 7 in the puzzle. Given there's a 7 in the puzzle, do I have to also have a 6 in the puzzle? If I have to have a 6 in the puzzle, it's going to go here, right? Because I can't put a 6 here. I can't put a 6 here because that would make it 6, 7. Let me back up a step. I said that incorrectly before. The 6 doesn't necessarily have to go here, but if this is the 7, the 6 would go here. And so this would be a 6, 7 pair. And so these would be the same if I also have to have a 6. If I can get away without having a 6, then I have more ambiguity, but you'll see that we can't get away without having a 6. So suppose there's no 6 in this 22 cage. Well, that means this is a 7, right? And there's no 6. So again, how do I maximize the rest of the grid? Well, I can't have 2 5s because I would need 1 here, which would mean D is not 5. The second one would go down here, which would mean E is not 5. So I can't have 2 5s. I can have at most 1 more 5. So I have a 7, and I've got a 5 somewhere to maximize this. Now, can I do 2 4s? If I have 2 4s, that would just barely get me to 22, right? 7, 5, 4, 4 is 20, plus 2 is 22. That just barely fills up the cage. So if I can manage to get 7, 5, 4, 4 in this cage, then I can do it without a 6. So how would I do that? Well, if I need 2 4s, then I would have to put a 4 here. And then these would be, in some order, 4 and 5. Okay? Well, what's the problem with this? The problem with this is the following. How do I... First of all, I actually can't make this a 5, right? Well, why not? If I make this a 5, then this sees everything in this box. So these can't be 5. In this 13 cage. So I'd have to have another 5 here. But now I have 2 5s that see D and E, right? This 5 sees E, this 5 sees D. And so I can't have a 5 here. I can't have a 5 here because that would... eliminate D and E from possibilities. So it would have to go this way, where I have 2 4s like this and the 5 here. But now I break this 13 cage with 4s, right? So I also can't have 4 here on this 13 cage because this 4 will see these 2, this 4 will see these 3. There'll be no 4 in the 13 cage. So I can't put 7, 5, 4, 4 here either because however I try to do it, that's going to break this. So I need a 7 and a 6, which means this is going to be the other. I can't put 6 or 7 here. I can't put 6 or 7 here given this purple cell. So these are going to be the same digit. I don't know what it is. Let's get a little more contrast. Call that blue. And now I have a 6, 7 pair here, which sees E. So now E is actually a 5, which makes D 7. And now I know that this digit, blue, is not 7. Because 7 is not one of the 4 cells that goes in the corner here. So blue is actually 6. Purple is actually 7. I'm going to get rid of that coloring now because we don't need it. And so now, if we think about this a little bit more, I definitely need a 5 in this corner. So the 5's not in here. It's definitely here. And then the other one is going to be A, whatever A is. Or C, actually, sorry. So one of these is A, and one of these is C, but neither of them is 1, is the point. So that goes like that. Okay. Now, the next step here is to think about 3s and 4s. So actually, one more thing that I forgot to mention earlier that's going to be kind of important here. These 5 cells don't seem that restricted, but they're actually quite restricted. And the way that they're restricted is the following. So if I add up these 3 cages, they're going to add up to, let's see if I can do, so 34 plus, what is that, 12 plus 17 is, let's see, that's 29. So that's 63, right? If I take out 45 from the square, that means these 5 cells add up to 18, which seems like kind of a lot for 5 cells. But one of those cells has to be a 9. Why does one of those cells have to be a 9? Because if I think about where the 5 9s are in this puzzle, right? So all the corner cells, there are 5 instances of it. So where are the 5 9s? One's in this corner, so I'll mark that here. One's in this corner down here, right? And then the other 2 are either in a windmill like this, in which case I have a 9 in one of those 5 cells up here, or it's in a windmill like this, in which case I have a 9 in one of the cells down here. So one of these cells is definitely a 9. So I have a 9 and a 1, and then 3 more cells to make 8. So now that is getting quite restricted. And then similarly on this 22 cage, how am I going to fill this out? Well, I've got 13, 15 here, so these are going to add to 7. This 2 sees both cells, so it can't be a 2, 5 pair. This 6 sees both cells, so it can't be 1, 6 pair. It's got to be a 3, 4 pair somehow. Right? So I have this 3, 4 pair. I know there's a 9 somewhere here, and then some pretty small digits that will finish up the puzzle. And in fact, I can do a little better than that, because now, before I do that, I should actually think about ones, and where do ones go in the puzzle? Well, I know there's 1 here, 1 here. There should be 3 more. So what are the possible windmills? I could either have it here, or more simply, I know 1 is going to go here because I'm missing a 1 in box 8. So if the 1 is here, where does the 1 go in box 6? Well, it can't go here because of that 1, so it's got to go here, which means I actually do get a 1 there. Okay, and so now I get a 1 in one of these spots and a 1 in one of those spots. Okay. Now maybe I should start thinking about the 3 4s going around the board. And real quickly, I'm going to say B is not 6 because 6 is in this corner cage. And so this cage is 2, 5, A, and C. This being one of these A or C's, and this one being the other 1 and 5. Okay, so now where do 3 and 4 go kind of in the rest? I'm actually going to go, these are A, B, and C. I did it when I was thinking to walk the right color coded them, but I'm going to try to do it with letters now. Well, where does B go in the rest of the puzzle? B is going to go up here. So this is actually 9 and B in some order. B is also going to go in here somewhere, right? And so my 5 Bs are here, 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 right? And here. So this one I'll label again as B. And then the other thing to recognize here is that B is not anywhere here. So whatever is not here, 3 or 4, is going to go up here along with 5 or 6. And 5 and 6 do not go here. So it doesn't quite give me what I need yet, but it should start making you think about, well, how is it going to work? Like, how am I going to get 3 and 4 and 2 in these cages? Because I need fairly low digits in these cages to get to 19. Sorry, not 19, 18. But I have a 9 somewhere in here. So actually, I think the next step is just to think about those. So where can the 9 go in this setup, right? Where does the 9 go? Because Suppose I put the 9 down here. Well, this becomes a 1-9 pair, right? And then how do I make, so that's 10. How do I make this add up to 8? Right? Well, I have a 1 already. So these two add up to 7, but 5 and 6 are taken. So this is going to have to then be a 3-4 pair. So if that's a 3-4 pair, that breaks B. So I can't have the 9 down here, because if I have the 9, again, if I have the 9 down here, then this doesn't, I can't get this to add to 8. So this would be 1, 9, some way of adding up to 8. There's no way I can do it without either breaking the column or putting a 3, 4 here, which breaks B. So I don't get a 9 here. That means I have a 9 here. It's not I actually want a 9 and here. Okay, well, so what is the other digit here? Because 2, 3, and 4 are taken in the column, sorry, in the row. So what is the least now I can make this? I could have 1, 5. That's the smallest I can make this. That's 6. And then I could have 1, 2, 9. That's the smallest I could possibly make it, and that's already 18. So that is just what it has to be. This is a 1, 5 pair. And then this is 2, 9, but the 2 can't be here. So this is 2, and this is 9. Okay. And now I need a 2 in box 3, which is going to go here with this 9. And then after this, we're going to take a look at this 17 cage, right? So what are these 4 digits? These 4 digits are 1, which is up here somewhere, 7, which I don't know where it is, but it's somewhere, right? A, which is only 3, 4, or 6, and C, which is also, 3, 4, or 6. So this digit is either 7, 3, 4, or 6. So can I make this 17? Or how do I make this 17? Well, I can't do it with a 2 here. Right? If I put a 2 here, I still need 15. The most I can make this is 5, 7. It's just not big enough. So that has to be a 9, and that has to be the 2. So now I know these 2 digits add up to 8. So how could I do that? Either 1, 7 or 5, 3. So I'm actually going to change this to a 3, 7 pair. Or 3, 7 is what's left in the possibility space here. These can't be 7 because they're in the 12 cage, right? And the most I could have is a 6. If I have 1, 2, 3, 6, that's kind of that is the smallest. That's the smallest I can make it with a 6. If I try to do 7, I can only have 5 here. It's not going to work. So that's that. What is it? I'm going back to my walkthrough to see here. Okay. And now, so I actually did a little bit of a different order, so my walkthrough is useless at this point. What is this cell? Well, it's not 3, 4, or 6 because it sees all 3 of A, B, and C. It's not 1 or 2. So this has to be 5. And that means this is now a 1, 2, 4, 5. So whatever A or C I have here is a 4. So I get 4 here, which means this is not 4. So B now is 3. These are not 3. B down here is 3. These are not 3, so that's B. That's 3. Sorry, that's 4. That makes A 6 and C 4. And now I know that these were A, B, C. So A and C are 4 and 6. I can't have a 3 here anymore, so that's now a 7. And that's 16, so that makes this the 1 and this the 5. I should know these digits all, right? So B is now, I don't need B's anymore. These digits are 3, 7, 5, and 9. These aren't 7 and 9, so these are. But I know 3 is here, so that's 5 and 3. I think at this point it's really just a little bit of cleanup. That's 4 and 5. The remaining digits here are 1 and 2, so it's 1 and 2. That's 7 and 9. Remaining digit here is a 6, which actually I don't know how it goes yet. B, what do we say B was? Was 3. So these two digits are, let's see, we need in this box, we need a 4 and we need a 7. 7 shows us that's 4 and 7, so that's 6. 8 and 6. This is a 1-4 pair. I see that 1 gives me the 4-1. 9-3 gives me 9-3. And what's left here is we need a 5. And so that's 8-5. And that is Squish Doku 240 by Die Hard. Which I thought was just a great puzzle. And hope you got something out of this. Hopefully now any Squish Doku in the future you are well prepared for. And again, thank you for getting my channel up to 100 subscribers. And yeah, that's it. Have a great one.